What I'm going to do today is sort of focus on some of the big data cloud trends that we are seeing in our industry, in our platform, and kind of extrapolate some patterns out of those. I'm going to tell a few stories as well as few trends that have emerged overall. So without any further ado, let's get started. Tim O'Reilly mentioned in his blog that data is the next industrial revolution. I couldn't agree more. Data is the new raw material for any business, on par with the capital, labor, and people. So it's extremely important, and I'm really excited to see the audience also and their passion around big data. Now, James Hamilton in his blog talked about today at the core of any well-run business is a massive data store. And the measure of the truly advanced company is the depth of analysis and the simulation and the modeling that runs against that data store. So it's truly important to today to understand the potential of this big data and the analytics and the questions that you can ask. Now, a web e-commerce company like Amazon.com could analyze large sets of user behavior, clickstream logs in order to understand purchase patterns. Earlier you saw social network like Foursquare and Zynga analyzes social and demographic market data of their users and their likes and dislikes to serve them interesting insights. There are customers on our ecosystem that a large retailer chain could kind of analyzes historical inventory data to stock up goods at the right place at the right time. And it's not just web companies, but also variety of different real brick and mortar companies as well as pharmaceutical companies they are actually identifying patterns across a variety of different adverse drug reactions that have occurred. So capturing data and that ability to distill knowledge from that data is, in fact, really a competitive differentiation. So I truly believe in that, and so for and I understand. From the old days, what has happened is execs from the companies knew what questions they were going to ask, and the questions actually drove the data model, which in turn sort of drove what to collect and how to store the raw data. Now, in the data warehousing scenarios, schemas were optimized to answer a given set of questions, and it usually prohibitively becomes very expensive to ask ad hoc questions and in a standard data warehouse scenarios and so forth, because you'll have to essentially do a full scan of data to answer questions for which you haven't pre-computed appropriate indices. So this limited the algorithms that could be analyzed, the data and so forth. As a result, when the market dynamics changed, execs were not able to get the answers to the new and different questions because either the raw data was not preserved or they were not having enough computing capacity available to run on them. Now what we are seeing is that the interesting philosophy of measure everything and the ultimate mantra of collecting as much data as possible and then worry about putting the right algorithms against those data sets and asking the questions. It's very important today to collect and collect the data at all phases and all aspects of the project and then apply the right algorithms. And this whole new kind of data first policy or data first philosophy, has changed how we store and analyze data. So this actually makes me think about big data clouds and why big data clouds are so important. Now, big data, of course, as most of you know, is not just about storing, processing, analyzing, but it's also about sharing, distributing, visualizing massive amounts of data so that companies can derive valuable business insights from the data, distill knowledge from it, and actually make better business decisions. So in today's world, the core of any successful data is the data they manage, and data it's managing, and its ability to effectively model that data almost in real time so that they can make their decision much more faster and rise to the top. So we have seen today that every click, every pinch, every swipe, every check-in, every share, we are generating tons of data, and ingesting, storing, processing, analyzing these data sets require massive amounts of computation, massive amounts of storage, and massive amounts of resources at their disposal. And this is where really cloud computing shines. Cloud computing, of course, is a disruptive force touching every industry today, not just limited to big data, but it lowers the cost, maximizes the revenue, and gets the work done really faster at scale. And has a low cost to entry overall. So the computing power, I believe, should never limit our ability to analyze intelligence. The cloud gives us that access to virtually limitless capacity and necessary storage and compute resources when we need it. So I truly believe big data clouds are emerging, and that's the reason big data actually exists. So there are some interesting trends that I'm seeing today around these, and one of the first ones is around the fact that we all have dirty data, and the fact that there are incorrect data associated with some fields, incomplete and outdated data, there are data duplication and so forth, and this limits what you can do with the data. So what we have seen in our industry today is, especially in the cloud side of analytics side, the fact that good data is always better than lots of data. And this brings us to our first trend that we are seeing with our industry is cleansing the data and being the first step. For example, having a few labeled images is much better than having millions of images if, let's say, you are doing image search. In order to get good data, it is important to kind of cleanse and enrich the data that we have today. Performing this data hygiene step and cleaning up massive amounts of data is actually not that a trivial task. It sometimes demands lots of human intelligence, and that's where we see lots of customers today sort of using Amazon Mechanical Turk. This is one of the stories that we have a large provider of a business listing company which has more than 20 million listings in the U.S. They have lots of data which is sort of in the duplication mode, and they need to remove errors overall of their current data set. So that these are some of the things like phone numbers and addresses and names and so forth, and this truly becomes important that when data engine processing, you need some human eye to take a look at those errors and actually make sure that these are the two sets of data which is actually same. So you need to just create a unique data set. So a lot of people are leveraging Amazon Mechanical Turk to actually kind of take advantage of these enriching data set steps before even they start processing that data set. So one trend that we see is like good data is always going to be better than lots of data, and so cleaning your data sets is extremely important. So then the next trend that we have been seeing today in our industry is the fact that moving data is extremely expensive when you want to move large amounts of data. So the lots of customers today are essentially pointing their data source to the cloud itself, pointing their data source, so they're putting the data in the cloud in the first place and then continuously adding and appending that data set. So when you have to collect the data set, and store massive amounts of data, cloud actually makes it very easy. You don't really worry about the underlying infrastructure. Cloud storage has matured in this last 4 or 5 years, and it's highly scalable, it's durable, it's reliable, and it's available. And most importantly, it is inexpensive, and it is getting ready and getting even cheaper every day. So moving data is expensive, but instead of moving data in batches, companies are pointing their data source to the cloud. Their web clients, their log generators are directly dumping data in the cloud. And this also has a side benefit to it, that if we want to share it with other partners or consumers of our data set, because it's available at a global level and everything has a URL, you can turn on the ACLs and actually share that data with others. So in this, to support this particular trend or the story, we have seen companies like Razorfish and others that are doing variety of different things. Now, Best Buy in this case went to Razorfish to analyze massive amounts of clickstream logs from their website. They analyze massive data sets of clickstream logs, provide patterns to their ad serving and cross-selling engines so that they can show their own targeted ad on their website. While clickstream logs analysis is not new in our industry, but what I learned from the story is that cost of storing and analyzing big data has significantly reduced. And if we ran some of they did some of their interesting analysis around the cost and then dumping data in a periodic fashion. They are doing it in batches. So their data sets in the old way resulted in upfront capital expenditure of $50K, but in the new way of the cloud services, they didn't have any capital expenditure, and the recurring investment, the recurring OPEX was $13K a month. Which thereby actually they were able to increase their return on ad spend from the last year by 500%. Every day they had 13 terabytes of logs getting generated, and it was getting pushed onto the cloud for storage. But if there is a mechanism to directly store data in the cloud directly from the data source in a background fashion, so it does not really affect the user experience, that is the trend that we are seeing today with lots of customers. So that brings now having discussed the cleaning of data as well as cleaning and kind of analyzing and storing the data. Now the third pattern and the trend that we are seeing is analyzing data in parallel. Of course, Hadoop and open source Hadoop has been discussed a lot in this previous speakers, and the ecosystem tools have given pretty extraordinary power to an ordinary developer and to do parallel computing. It's now easy. It's now feasible. And Hadoop in the cloud has given the power to any developer or business to do pretty extraordinary things. So we are seeing that leveraging variety of different open source tools, not just Hadoop, but even there are other tools that are available that like MPI and so forth have done wonders today. And lots of customers today do take advantage of how they are going from a step-by-step fashion and leveraging the cloud to its fullest potential. Now, of course, we know Hadoop breaks the big chunk of task into multiple smaller tasks. Each task runs on a simple mapper, then it gets shuffled, and then also when in a reduced phase, all the keys get merged to give you the aggregate information, and then you can run these steps in a cascading fashion all over continuously. So these by running Hadoop and running that in an on-demand infrastructure gives you the power and so forth and enables you to pay for what you want to explore instead of prepaying for what you might need. And that is a very powerful model overall. So now Amazon has Amazon Elastic MapReduce, and lots of customers, like earlier you saw Foursquare and Zynga, they're leveraging this massive computation platform along with the power of Hadoop. What it does is essentially, each MapReduce job flow, creates a name node, it's a Hadoop stack, runs multiple task nodes and core nodes. They get data from HDFS, and then the data, which is actual raw data stored on S3, is computed across these multiple mappers and reduced and then gets computed stored into other data sets like S3 and SimpleDB. One of the interesting things that I would like to focus on is the use of Hive and Pig. Hive and Pig are very similar products are in the ecosystem to achieve the same results, but their approaches are very different. Now, Hive is more closer to SQL and makes it more amenable to data warehousing style use cases, while Pig and Pig Latin, which is their SQL-like scripting language, is more having it's slightly better sweet spot for ETL type of jobs, and it is very important to understand the importance and the differentiation between Hive and Pig, and I think both are complementary to some extent. Both can do the same job, but it is important to understand what type of job you have, and based on that, go backwards and use the right tools. The important thing that I would like to kind of focus on is that you don't know what would you use before you start analyzing. So it's important that you should have this choice, have this platform of choice that you can use, whether you want to use Hive or Pig or whatever, against the data set that you already have. And the thing that I feel is very important around this is the fact that the platform of choice. Now, several customers today, like Vimeo and ScribeDB, have been using a variety of different ways of big data analytics. There are, of course, things like Hadoop enable ad hoc analytics, but running such things in an Elastic Cloud gives you much more power to do parallelization in a short period. For some questions, for some of the customers we see, they want real-time answers, so they are leveraging the HPC cutting-edge, Intel Nehalem architecture, 10 gig Ethernet across full bisection bandwidth across two EC2 instances on the top of Elastic MapReduce, and so forth, because they want that high performance out of it. Some customers are seeing that they can afford to wait for a long time, but for that you want the cloud that supports low-cost computing, such as like offered by spot pricing. So in this case, they take advantage of the spot price model, decide what pricing or what price they want to pay for that particular workload, and then decide. For example, Scribe had this interesting project in mind when they moved from Flash to HTML5. They had to convert all the millions of documents that they have available to in the format that HTML5 supports, and so they ran everything in spot instances in a background mode when there is low-cost computing, and they're converting all that data jobs which are for time-insensitive tasks essentially, and then taking advantage of the spot market pricing, and that reduced their overall cost by 63%, and that's pretty cool to see. And of course, the ability to expand and shrink it gives you the flexibility of how fast or how sooner you need an answer to your question. So by taking advantage of these tool set, we are seeing that when we go out, we understand the potential of the cloud and potential of the open source tools. There is this ability, this platform of choice to give you all the choice that you need around to have that big data powerhouse, or what I call the Elastic Supercomputer. So there are several of these stories around that. Most of you might already know Flightcaster. This is one of my favorite examples. They use Hadoop, they use the cloud, and they actually tell you your flight is going to be late or delayed 6 hours before the airline knows it. And it's pretty powerful to see what goes on around the system. They take advantage of some of the real-time data, as well as they take advantage of the historical data of the flights that are coming from air traffic control, and then they sort of mash up the private and the public data sets in order to actually give you much more value overall to the end user customer here. Now, another example here is Etsy.com. Etsy.com is an e-commerce website for vintage and handmade items. One of the best things about Etsy is that people love to browse on Etsy. And some of them spend more than 9 hours a day to just find out interesting items that they have on the product, and they make it very easy. And there is how do they make that easy is by deep search metrics. They don't really just have basic things like visit metrics or how many times the product has been viewed, but they have very interesting things. Like if user searches for X, click on an item Y, then they buy Y, and then they show that results to the customer. So customer is more interested that if you have bought this product, more on the recommendation side as well. The one thing that came out from this interesting conversation that I had with one of the data scientists was that they're constantly facing this trade-off between optimization of analysis versus the cost of the analysis itself. Now, do you have to continuously analyze and optimize their current data, or they want to run multiple experiments in parallel and see which experiments run well? And what came out of was that cloud is really the potential here and the ability to iterate very quickly. Experimentation is extremely cost of experimentation is extremely low, and it makes big data analytics even more smarter. So in the case of Etsy, they really don't perform more optimization, but they keep on analyzing with more different ad hoc style use cases, and then ask different difficult questions all the time. So this is essentially leveraging the Elastic Supercomputer at your disposal to do multiple cool things. And the last pattern that I am seeing with lots of our customers today, and this might be very obvious and very simple to understand, but it gives you the importance when you are building a big data platform in the cloud. And what this pattern is essentially is that what I like to call this is a two-tier model for big data processing. Lots of customers today do this in a fashion that there are lots of data. They analyze data in parallel. I call that batch tier, and then they store that indexed, aggregated data in a separate data store, what I call the query tier. What this allows you to do is essentially, not only take advantage of Hadoop and other technologies that are out there, so that you can compute data in parallel, but then also allow you to sort of query data in real time, and because of that aggregated data set that is already pre-computed for you, and also does an ad hoc analysis every night with the newer data set that comes along. An interesting example here is a Recorded Future. Recorded Future uses the cloud to kind of predict the future by analyzing the past. They take lots of Twitter streams, blog, HTML content, historical content, and then they compute what they call the momentum, and use that in their advantage to predict what is going to happen 2 days from now. So they did, and their results are astonishingly correct. And I've seen some of those examples that they have. What they do here is they compute all that data using parallel computing technologies, and then dump that into MongoDB clusters and so forth. So like having an ability to do that gives them this enormous power to query almost in real time and give that much more information overall. The other example is Yelp. Most of you might already know Yelp is a location-based event companies where they're growing very rapidly, and in that particular in that scenario they compute they do lots of pre-computation using their own library called Mr. Job, which is a Python-based interface on top of Hadoop on the side of MapReduce, and they have they do this recommendation. People who have viewed this profile, this location, have also viewed other locations, and they have the review highlights and so forth. And they ask this tough questions all the time. That what are the top searches? And all these are pre-computed, stored in a separate data set apart from overall the data inside in using Hadoop and so forth. So these types of use cases, these types of trends that we are seeing today are enormously taking advantage of the cloud, not only because cloud can provide that computing resources, but also the cloud can provide the choice. They don't know which algorithm they might use, which tool they might use, whether they want to use Vertica or whether they want to use Hadoop or Hive or so forth. But storing the data once they can have that platform of choice in a way. So that what I truly believe is clouds accelerate big data analytics, and these patterns kind of are very simple to understand, simple ways, but do exist. And if you are a newer budding startups or a large enterprise taking advantage of the open source big data stacks, these are some of the things that I think you can take advantage of in your venture and will help you in going further very quickly. This is what I have. Please get back to me. I would love to know more about you and learn from you as well. So thank you very much for listening. This is my email address, and I would love to take any questions if you might have.
Thank you very much, Jinesh. That was a great overview, and I didn't realize you were going to cover quite as many different companies in this space, but I'm happy to see the sort of cross-section of ways people are using big data, particularly since the theme of this Strata Online conference was startups and disruption. It's pretty clear that a lot of these startups are disrupting their spaces with data analysis, and it seems like they're doing it with access to this Elastic Supercomputer you referred to without a lot of upfront capital. So, how is that changing the nature of startups and how quickly they start to crunch this stuff? The fact that they can pay on demand for the infrastructure needed to do this compute.
I think it is changing very rapidly. As you heard earlier from Justin, Foursquare and Zynga, there are several of these startups. Some of them are based on Hadoop, some of them are not, and the technology really doesn't matter. These might change in future, but the access to massive computation power, the access to storage, the ability to do big data without limits is extremely important, and that's what we are seeing with newer startups today, that they don't really care about what platform to use and what to use, but they do have that access without having access to the resources, without having the capital expenditure up front. And I think that is giving them enormous power to experiment overall, and get the results much more quicker. I'm not sure I answered your question, but we're seeing several interesting startups platforms coming up. There's an interesting company called Good Data, which is a BI analytics company on top of EC2 S3, uses lots of our lots of Elastic MapReduce services as well. But they are essentially a big data platform on the top of the cloud platform. So there are interesting patterns, and of course, cloud is the platform for platforms. So you're seeing interesting platforms that are coming up, very quickly. Good Data was again one of our startup challenge winners in the last year.
So I have a related question to that, I guess. There are cases where someone can go and get a service, let's say a Karmasphere or Cloudera, or they can use your, actually more accurately, Cloudera, or they can use something like simple Hadoop from you guys. And there are other cases where someone may want to stand up virtual machines on a cloud and implement their own stack and run it themselves. Why do you see people making a choice to go one way or the other? I mean, you have people that clearly are running their own stuff, and you have people that are building platforms like Good Data, like simple Hadoop, and they come to you and just run a job across it. What usually influences that decision?
Yeah, that's a great question, Lister. What we are seeing today is not just Hadoop in our platform, but also things like OpenMPI, other cluster technologies, and so forth. For example, there are several pharmaceutical companies taking advantage of the cloud infrastructure to do DNA analysis, protein docking calculations, and so forth. And that doesn't really, Hadoop is not solving that problem for them, essentially because of the two things. Hadoop is slightly different technology for them, and it doesn't do certain tasks that they are accustomed to, and their data sets is sort of different as well. So when they come to us, they say, we ask them certain questions about what is right technology set for them, and these companies, these enterprise companies, have their own software that they have built and maintained over the years. So it is depending upon what type of workload they want to have, we suggest them the right tool set. Again, the power of the cloud is that it provides you that flexibility to run any of that, or whether it is just Hadoop or whether it is their own stack that they have. And depending upon the right questions that they want to ask, we will suggest them the right technology set.
So let me ask you a question you may not be able to answer, but I'll ask anyway. If I were to, given a particular workload, if I were faced with the choice of using a turnkey Hadoop service where I just specified my job and it ran, like the simple Hadoop stuff, versus going and getting a bunch of virtual machines and configuring them to run a Hadoop cluster of my own, which one would cost me less and which one would run faster?
From the performance standpoint, I don't think so that will be any different, whether to use Amazon Elastic MapReduce, which is a pre-configured Hadoop stack on EC2, or whether you want to run Hadoop on plain vanilla VMs overall. What I recommend, and also what I see people are doing, is if they have Hadoop as a use case, and they know that Hadoop is the right solution for them, they totally understand and they move very quickly to Amazon Elastic MapReduce, because it truly abstracts out all the complexity that Hadoop brings in overall. So 15% more than their actual cloud infrastructure, but it saves them a ton of time to install, configure, manage all that jobs. So if they want to do ad hoc analysis, Elastic MapReduce is the way to go. From a more flexibility perspective, and if they are hardcore Hadoop tuning experts, they know how to tune certain things, and they want to really get to as close as they can get to the Hadoop internals and then tweak certain aspects, then we advise them to run their own Hadoop stack on EC2. So it depends really about I'm going to give you a consultant answer, right, which is like it depends. But yes, it does depend upon the use case. It does depend upon the expertise, and it does depend upon how much time they have overall to process that data set. Whether they want to really get up quickly, compute, and then get their jobs analyzed very quickly, or they want to go tweak, optimize, and so forth.
Okay, great. I got one more question from Richard H. in the chat here. How many big data users dump their data? How often? How to decide when to keep and when to jettison? And I guess in the case of a utility world, because you are paying for the storage of data as well, that becomes another factor. Do you have any insights into how long people keep the data for, how often they dump it, and stuff like that?
Again, it depends upon the use case and depends upon how much data they are storing, or how often they are going to access. There are some customers who take advantage of the reduced redundancy store, which is a lower redundant offering on the top of S3. It is at 10 cents a gigabyte per month versus 15 cents a gigabyte per month. In that, they know that they can, if they want the data, if they lose the data or they want the data again, they can quickly pre-compute that data again from that existing data set. Or there are data sets, some companies like Add Knowledge who just put raw data, quickly compute pre-computed data, and then delete the raw data because they feel they will never ever use that compute data, that raw data that they have. They only are going to use that analyzing for reports and analyzing that pre-computed data sets or indices. So it depends upon the customer. Some of the big data users that we have seen, like Vimeo and some DNA analysis, they really don't have that much data because they are computing on a very small data set. Like if they're doing DNA analysis, you have a small data set. They don't have large data sets, and they are computing a lot. They're essentially a compute intensive versus data intensive. So if there are certain industries that you would like me to focus on, let me give you back. Please get back to me via email, and I will get the right use case around that industry specifically.
And I guess you have to do a sort of back of the napkin spreadsheet calculation on the cost of bandwidth to re-upload your data versus the frequency with which you're going to access it, times the risk that data might go away because you're paying for a less reliable store. And that's a sort of spreadsheet model someone can calculate based on the size of the data set and frequency of access, right?
Absolutely. So there's a company called Complete Genomics, which essentially takes your blood sample and create your own genome. And they have a highly compute-intensive task. They take advantage of AWS import-export, where you dump your data in a hard drive and import and ship it to Amazon, and Amazon will suck that data and put that into Amazon's S3 and so forth. Or they do the other way as well. Once they have computed that data, they want that data set to them, exported in a hard drive and mailed to them. So they feel they want to take, in their case, it is more about more genomes, and they don't know what really everybody would be doing about genomes in the next 2 or 3 years, but they're essentially a genomics company, and they want to have people access to the data set and create a way by which, whether they want to use Amazon Elastic, they want to just upload the data, or they want to take advantage of import-export where they ship hard drives, and they do that, run their Excel sheets. They found out AWS import-export does make more sense cost-effectively as well as from bandwidth perspective.
Interesting. And that brings us right back to Jim Gray's comments about never underestimate the bandwidth of a station wagon full of hard drives driving down the highway when you find out that Amazon actually has an API that's focused on, when you consider FedEx as an API. That's an interesting state of the world. Okay. We have to finish up now. Thank you very much, Jinesh, for going through this. I know we did ask you to come in here and talk about a bunch of different things running on the Amazon platform. I appreciate you keeping it focused on how it's getting done and not the specific offerings. Good insight into the number of things that are being built atop cloud platforms like Amazon's. I want to thank all of our presenters. This was a lot of content to consume for 3 hours, and I'm very happy with how it went. And I want to let you guys know the next event we're running is on personal analytics. It's a pet interest of mine, looking at life logging and tracking data and tracking and maintaining one's personal information, getting insight into everything from health to social graphs to reclaiming all the information that people like Facebook know about you. Very much looking forward to that on July 12th. We hope you can join us. And, of course, we have 2 upcoming Strata events, one which I mentioned earlier in New York, September 19th to 23rd, and one next spring in February in Santa Clara. Thank you all very much. Thank you to our presenters for joining us, and appreciate everybody spending so much time with us today to talk about this fascinating subject.